Hello everyone. This session we will start with the logistic regression. In the previous session we have discussed the linear regression and the different techniques those we use to implement the linear regression problem. So here first we will discuss what is the main difference between linear regression and logistic regression. So here the main difference between linear regression and logistic regression is linear regression is used to solve the regression problems and logistic regression techniques are used to solve the classification problem. So why classification problem? Because in the logistic regression the outputs are discrete values, the outputs are categorical values, and here the outputs are the continuous values, continuous numerical values. Okay? So if my outputs are continuous numerical values, we can solve this problem using linear regression techniques. And if my outputs are categorical values, it comes under the classification problem. And one of the technique to solve this problem is the logistic regression. So this point you can note down, student. Here are some examples for the linear regression, predicting the GDP of a country, predicting product price, etc. Here is the example predicting whether an email is a spam or not. So here spam or not spam will be my category, right? My output will be spam, not spam, right? Predicting whether the credit card transaction is fraud or not, right? And another example, predicting whether the customer will take a loan or not. These are the best example of logistic regression problems. So here, see what we use, right, to solve the linear regression problems. Actually, in the linear regression, we find the best equation of the line. That line best fits my all the data points given in the data set. If you observe, student, my data set is made up of a two dimension, experience and salary. And all the data points are here pointed by the green color are lie on this line. So this is the best line that is used to build this regression problem here. So here my objective of the linear regression problem is to identify this best line where my error will be minimum. So the equation, this model is represented by the linear regression model is represented by here the equation of the line. So what is the equation of the line? Y equal to A0 plus A1x. So where A0 and A1 are represented here coefficients, right? So these are also called as A0 is called as intercept and A1 is called as the slope of the line, right? So by changing the slope of the line, you can change the direction of this line. So your line can be like this, your line can be like this, right? It is a role of the developer of the machine learning model to find this best line which will fit the data points exactly on this data line, exactly on this straight line. So if my line is a straight line, it is an example of the linear regression problem. Okay? And if means my objective is here to minimize the error. Error means what? The difference between the distance between the data point and this line. The objective of this linear regression model is what? To minimize this distance between the data point and my line. Practically, it is not possible to find the best line that will cover all the data points exactly on the line. And that will go under the overfitting problem, right? And that's why our objective is to minimize this distance between the point in the data set and from the straight line that we have found as the best model for the given problem or for the given data set. I hope so you are clear with this. Now in the logistic regression, logistic regression also we find the equation of the line, but this line acts as a separator for the class, number of class in the data set. Here is the example of binary classification. Right? As we discussed, logistic regression techniques is used to solve the classification problem. In this model, we use to classify the data set into the number of classes. that is given in the data set, training data sets. For example, this is the example of binary classification problem. So there are two classes, class 1 and class 2. So our objective is, the objective of the logistic regression is to find this best hyperplane. This straight line is also called as the hyperplane in the regression problem here, to find this best hyperplane so that there will be minimum misclassification, minimum misclassified data points. So again, it is the role of the machine learning model developer to find this best hyperplane. So there can be multiple solutions for the given problem. For example, this is the best hyperplane that we have obtained for this given data set, where my number of misclassifications are 0. All the blue color points are classified here as a class 2 and all the red points are classified as a class 1. So if you find this line, right, this can be one of the solution. Means this line, this hyperplane also classify your data points into the two classes, right? Also this line, it can also divide your data set into two classes, class 1 and class 2, but these points will be misclassified. Even though the class of these data points is class 2, this hyperplane will classify these data points as a class 1. So misclassification is there, right? So like this, by changing the slope of the line, you can find the best solution. And you as a developer, it is a part of your research work, right? By trying the different slope of this line, you can find the best line. So that is the optimization problem. The optimization problem of this logistic regression says what? By changing this slope of the line and checking the number of misclassification or checking the accuracy of the model, you can find the best hyperplane that will divide your data set into two classes here for this example. I hope student you are clear with this. So in the logistic regression techniques, we use this logistic regression equation, right? So this equation also represented by this formula here. So here we use this equation to find the probability of the query point for the given probability of the class label for the given query point, right? So that we will discuss with one example. Before that, just see here we find the probability of the class for the given query point. So this probability can lie between the 0 to 0.5 or 0.5 to 1. So this is the sigmoid function we use in the logistic regression to plot this model, right? If my probability is less than 0.5, if the probability that we have obtained for the given query is less than 5, then this query will belongs to the class 1 here. And if this probability is above 0.5, then that particular query will belong to the class 1, right? So here is the example.